So welcome back to the program. Happy Thursday. No?
Yeah.
Yeah. Happy
It's
Thursday.
garbage day on my side of town.
Okay, happy garbage day for those of you in Solon, Oxford, and where do you live?
Well, southeast Iowa City.
Southeast Iowa City. All right. So happy garbage day to all those celebrating garbage day today. Not quite sure celebrate's the right word, but you know, it's a thing.
We're
I
Oscar.
do feel real relieved when my recycling gets picked up.
Yes, I can agree. Like, it's just piles up, and if you don't rinse it well enough, then you start to have bugs and things.
Yeah,
So
or the dogs get curious and you have to go and chase them around
yes,
the yard.
pets get into it. Wind blows it everywhere. Yep.
Green Muppets.
Green Muppets, like Oscar.
Yeah.
Yeah, I loved Oscar the Grouch. He was my favorite. I had an Oscar the Grouch doll. So, yep. It's like people are like, "Oh, I never saw that one coming."
What are the names of those two Muppets, the grumpy old guys?
Stadler and Waldorf. Is that right? Someone asked the internet the name of the old two Muppets that were grumpy. I'm pretty sure one's Stadler.
That's what my dad's turning into, but we can unpack that some other time.
Yeah. Grumpy Muppets. I love the Muppets. There's no such thing as a bad Muppet. Anyway, I have the syllabus up. Do you know why I have the syllabus up?
So we're changing things.
We're changing things, but you're going to like it. So I went through the syllabus and realized how compressed things had gotten. And if I push the next homework back, which is what I initially thought I would do, I realized we were going to hit the point where I would not be available because the week of October 9th, Jonathan and I are hosting a conference here, so I will not be available from Wednesday on, and I did not want you to have anything due that you would need help with while I was not available. So the long and short of it is homework 3 is canceled. Your next homework is not due until the end of October, which was homework 4, which is now homework 3. So less work. Is anyone sad about that?
Nope.
Didn't think so. No one's ever sad about that. What I do have, though, is the next thing that you can be working on is formative assessment number 3. That is open. I sent out an announcement about that, I think, yesterday morning. And that is a story problem where after today you should be able to answer all the pieces of that, but certainly we will go over it, so give it your best shot. Another thing that I posted is now what is going to be homework 4. I have made a slight modification to my original intent. So I have a document posted where it says homework 4 plan is due, and I have that up here. Let me grab it for a second so I can show you. So homework 4, the idea is to give you some sort of individualized practice doing these kinds of analyses, to take the training wheels off, let you actually try to analyze some data. So I have 2 options for what you can do because I recognize that not everyone is going to have data that they care about. So here's what I would prefer that you do. This is what I would like to have happen if it's possible for you, is to find data that are meaningful to you in the context of your research, your employment, or whatever else you're doing, and do some clustered data analyses. So the parameters are described down below. I have some links to some publicly available data that might help in finding some data if you don't have any already. And if you're willing to do that, then I have 3 questions that I want you to answer and turn in. That way I can weigh in on your analysis plan and what you want to do so that you've got everything set up for what you would eventually do to complete the assignment. If you're like, yeah, I don't have any kind of data and I don't know where I would get some, what else can I do instead? Then you get to do some writing, but of a different kind. So this assignment will be your chance to, I'm going to say, detect inaccuracies, more informally bullshit detection. Everyone and their dog is using ChatGPT and other similar AI things to answer questions and get information, right? Your task is going to be to respond to some prompts and answers that I generate and tell me what's right and what's wrong. See if you can detect, based on your knowledge, how accurate the information that is being provided is. So that is the other option for this assignment. That way they're both written assignments without the same level of scaffolding that I normally do. And it'll be up to 9 prompts. I'll have to see how complicated they are, but it would be 2 to 3 points apiece is the way I'm thinking of it. So these are the choices for your homework 4. You can decide by the 16th of October which you want to do, And then inside icon, there is an assignment where you can either answer a multiple choice question saying, I'm gonna do the AI thing, or I'm gonna do the plan, and here's my plan document. So you have until then to decide. Once I get the plans back and I see what folks are doing, I will put together a more specific list of like criteria as to what your assignment would include. But this is not a paper and this is not a project. This is supposed to be at the level of an assignment. So it would predominantly be a results section focusing on some analyses that you did, maybe like an intro paragraph, a discussion paragraph, and a little bit of a method section so I understand. So not a whole big thing. But the idea is that this would be the skeleton of something that could turn into a publishable product or a conference presentation or something like that. That's the idea. Question?
Like a master's thesis?
It could turn into a master's thesis, yes. And by the way, double dipping, highly encouraged, okay? Are you familiar with this expression? It means getting two things or one thing to count for two things. So if there's something that you wanted to do or needed to do anyway, this is your chance to get class credit for it and get my feedback on it. So, I'm willing to be flexible in terms of the scope of things. For those of you who've had additional coursework and you want to take like this type of content and do something in addition, like do clustered analyses on latent variables or incorporating longitudinal information, clustered longitudinal samples. I know a few of you have stuff like that. If you've had the longitudinal part or you've had the latent variable part, I'm willing to let you make it a little bit more than what it would be, but it doesn't have to be. So I wanted to make sure everyone knows those things are available so you can start thinking about what you want to do. So just to recap then, on the 19th, there's nothing due. On the 16th is when the plan is due. Then we have another formative assessment, and then your next CAN data homework won't be until the end of October, and that'll be on random slopes and cross-level interactions that we're talking about now. So hopefully by the end of October, you'll feel a lot better about those things and ready to go onto the next frontier. Right? Yeah, space. Cross-level interactions, the final frontier. And I want to point out something I don't normally emphasize. This column on the right here, readings. So it's my job, I feel like, to get you started on concepts, application, how to do things. But I think it's important and useful to read other people's descriptions of the same thing, because the more different ways that you hear it or read about it, the more it's going to sink in. So with the extra time that you would normally be spending on homework that I'm not asking you to do, you can start working your way through some of the articles that are on the reading list, and hopefully that will help you. I did notice that I forgot to put mine in your packet, so I added that to icon. So I just assumed you'd all have it, but that one is a very long one. It's an overview, and I think that might be a good place to start. Otherwise, the ones that I'm citing inside the presentations in particular would be ones to focus on, and especially. So just to remind you, these are other resources that should hopefully help things sink in differently or more thoroughly than what I can do. Rather than just rereading the slides, reading other people's descriptions of the same thing should help. All right, questions or comments on any of that? Zoomer's good? Rimmer's good? Yeah. I like thumbs.
Yeah, but my opinion doesn't matter of
Well-
whether we can move on or not.
But your participation is appreciated.
Yeah, exactly. Participation is appreciated. Yes. All right.
It's not fun when you're up there and just like, cricket.
Yeah, yes, exactly. Nobody likes crickets. Full of rhetorical questions, that's what I am. All right, so let me know if any of this is unclear or you're not sure if your idea is going to work. I'm trying to be flexible, but it does need to be something clustered multi-level. Like, at a minimum, we got to have like the name of the class as part of the analysis. Beyond that, I can work with you. Okay? Yes. Or the cat. I can work with the cat. All right, let me see here. Let's go to this idea. So what did we talk about last time? That, the thing that I have on the board, or this. What's a random slope?
I have a question.
Okay, I'll
That
take a
might-
question first.
Be related to answering that.
Sure.
Is the random slope for each variable in the cluster? But like, I know each bee has its own, actually, maybe just keep going and we'll
We got
follow
some
it.
hand gestures happening. Yeah, I would take this as an answer to what is a random slope. Different slopes.
So is that the cluster mean that's varying? So each different angle is a different cluster, or is it a different variable within
So,
level two?
so the question was, is the cluster mean that's varying? That's not the random slope, although the cluster mean does vary. We have random slopes are different slopes per cluster group. Yes, that's the idea, is that you have a level 1 predictor, which is a person thing, and you are allowing the extent to which your person predictor predicts your person variance in the outcome to vary across clusters. So like, it's bad to be a poor kid, right? That's all of the SES academic achievement literature. Is it as bad to be a poor kid in some schools, or is it worse in other schools? That idea. Does it matter more? Does the effect of this predictor matter more in some contexts, in some clusters? The idea of a random slope is that you're adding a source of variance across clusters that's not in the cluster mean, because that's what the intercept is for. This is a second type of difference across clusters in the slope of a level 1 predictor. That's what a random slope is.
So in a regular one level regression, you can't have a random.
You cannot. In a
There's no
one,
between.
yeah, so like if you're talking about just a standard general linear model, like regression thing, random slopes are not things. Because you have to have another level for it to vary over. For the same reason, you can't really have a random slope of a level 2 predictor. Technically you can, but it means something different, which is why I'm not talking about it. But the idea is that it's a variable as a predictor at one level can have a random slope at a higher level than it was measured, not the same level. That's the big idea. So fixed and random go together. Fixed is the average, random is how far off the slope is for your cluster. So like the heavy black line in these pictures is meant to convey a fixed slope, whereas the individual lines are per cluster. And what you're not seeing in these pictures is the little dots that would be around each of the lines, because I thought that would make it too clunky. Which is why I like this picture that I stole instead, that has the little dots around the lines. So they have clusters in different colors, and then we have slopes going through each of the dots. So the dots are level 1 people. The line is the slope that relates this level 1 person variable to our outcome. And the fact that the lines are different across clusters means that there must be a random slope in the model. So that's our new friend U1 in the equation. If WCX for within cluster X is the level 1 predictor that has the random slope. That's the big new idea. So we had, I think we made it past this point, but this was the first time you saw a random slope in generic notation. Okay. Let's see, where do I want to go? Yeah. Questions, let's do that. Questions, thoughts, things you want to clarify about random slopes?
So, you probably covered this already.
I may have, but we're going back over it for good
But-
reason. This shit is hard.
Okay, so the random slope, it's a level 2 thing. And it's
Yes.
how far off from the average your thing is.
Yes, but let's put some better words in for thing.
Your cluster slope is.
Yes, so U1 is how far off the slope is for your cluster, like cluster C, whichever one that is.
Right.
And it's off of the fixed slope.
Right. That I get.
Okay.
But, and then you just said we can't have the random stuff at level 1. We can't have a random slope at level 1? Or did I misinterpret that?
No, that is true. Random slopes are at higher levels.
Okay. Now, here's logically where I'm struggling with that a bit. So at level 2, we have things we have clusters that are off from the average cluster.
That is U0.
Yes.
So the idea that some clusters have higher means than others,
Right.
that's U0, that's random intercept.
Yes. At level 1, we would have folks that
At level 1, people differ from each other within the same cluster.
And that's,
That's E.
yes,
Mhm.
and that's, residual.
That's level 1 residual. Yep.
Okay, so I forgot terms, never mind, logically it makes sense, vocabulary-wise, I was
Vocabulary.
struggling.
Yes, this is a
So-
vocabulary review. Yes.
Okey doke.
So this model, let's go to this slide here. No worries. No, it's good. This is good. This is what I want. Because I realize when I start talking just how complex this is, like how many words I have to fit in the sentence for everything to be correct. That creates a big working memory like load, and
Oh,
I
yeah.
don't want that. So the way to eliminate working memory load is automaticity. You got to have things like just come automatically. So drilling the vocabulary until we get to that point is going to be useful. So this model right here, what do we have in it? Okay, let's go back over just the basics. What's Y?
The outcome.
That's my outcome. Why do I have a PC on Y for subscripts? Person and cluster. People are level 1, clusters are level 2. Then I have beta 0C. What's that thing? This thing right here.
The placeholder for
Yeah.
the cluster intersection.
It's a placeholder. It's also, you can think of it as a latent variable. For those of you who've had SEM, that tie works. But beta 0C is in black here because it's not a parameter. What it does is hold the parameters that are needed in order to give each cluster its own mean outcome. So this is like an instruction list here, or a recipe. How does each cluster get its own mean according to this model? Well, it starts with some sort of reference point. That's my fixed intercept. I like to think of the fixed intercept as like the "you are here" sign in the map of your data. It's everything is relative to that because you talk about a 1 unit change up or down. It's relative to the intercept as your reference point. So gamma 0, 0 is my fixed intercept. It always means the same thing. A fixed intercept means the same thing regardless of what model you're in or what class you're in. It is the expected outcome when all your predictors are 0. So in this case, it is the average outcome when my level 1 predictor 0 and my level 2 predictor is 0. Then we pick up gamma 01, which is in this model a between cluster slope, because this is the cluster mean of my level 1 predictor. So like average money for the school, that kind of thing. Gamma 01 is a slope. So the change in Y for a 1 unit change in X generically. More specifically, the between effect is the effect of having more X on average in your cluster than other clusters without controlling for the person version of X. So this is all just focusing on why some clusters are higher or lower. This is potentially one of the reasons why I have my cluster mean of this predictor, like mean money for the school. So for every unit more I have of this variable, my school's mean outcome goes up by gamma 01, the slope coefficient. Now, this part here is going to create the same predicted outcome for any cluster that has the same value of the CMX predictor. So 2 schools that have the same amount of mean money would have the same predicted outcome. But their actual mean is probably not going to be perfectly predicted by just this thing. So in this model, U0 is a random intercept. U0 is representing the idea that we have a variance across clusters in this intercept. And it is a deviation for how far off the cluster mean is from what is predicted based on the fixed effects here. After controlling for like school money, how far off is your intercept for this school, for this cluster? So the effect size for cluster mean X here would be the reduction in level 2 random intercept variance. Why is it that some clusters have higher means than others? Because of this variable. Okay, how much of it is because of that variable? We compute a pseudo R-square for that proportion against an empty model. Okay, with me so far? Okay, so now we backpack all of this stuff together here into my beta 0 placeholder and go back up. Question? Question? Someone talking?
Somebody said Lisa,
Yeah.
sorry.
Someone said my name. Okay, I'm not hallucinating.
Maybe I am.
Maybe
No,
you are.
I heard
Okay.
it too, yeah.
Okay, someone of the Zoomers is trying to talk to me. Can I pause a minute? Sure. Yes, it was me. Okay.
Yeah, I like interpreted it as like a panic, Lisa, like, wait before the next idea.
Yeah.
Yes,
I'm
happy to do so. How about I have a sip of my caffeine-free soda? It's pretty good. Orange Crush. Now we're ready. Okay. You can always tell what was on sale at the grocery store by what's in my hand. It's like today it's Orange Crush.
Do you buy them singular or do you buy a case?
12 packs. Even though 12 packs like cost more than anything right now.
Hmm.
Yeah. Does it count if I go on a digression so you can keep writing? Because you're probably not taking notes on orange soda. Okay, now we're ready. So, wrapping up here. Beta 0C is how each cluster gets its own mean. Part of it is from known things, the model for the means fixed effects here, and part of it is from, I don't know why, but they still need one. So U0 is, I don't know why this cluster is still higher than what's predicted or lower than what's predicted. It's unexplained variance, it's error variance. So all of that stuff goes into beta 0, comes back here. Then we pick up the next predictor, which is a level 1 predictor, which is a person characteristic, and this predictor has been cluster mean centered. That means we have subtracted out cluster mean differences in this predictor when we built it. We have manually created a variable that only has within cluster level 1 variation. That means that what its slope in the model has to be is the within effect, which is the idea of having more x than the rest of your cluster. How does that affect your outcome relative to the rest of your cluster? And we know that this is going to be the within effect regardless because the variable that it is attached to only has within cluster information. That's the key idea here under cluster mean centering. I've left open this blank spot in here because we're going to fill it in shortly. But at the end of this is U1. So in total, how each cluster gets its own slope for the effect of my person predictor here is the fixed part in red, the gamma 1,0, that's the average slope across clusters, plus U1, which is how far off my cluster slope is from the average. So if this is a positive slope on average, and I have a positive U1, that means my cluster has a stronger relationship between my person predictor and my person outcome. If this U1 were negative, that would mean my cluster has a weaker relationship, less positive, of my person predictor with my person outcome. This is where the wording gets tricky, because U1 is a level 2 thing. U1 is a cluster property. U1 creates a cluster-specific slope of a person-level predictor. These will be drop-down menu questions, I can guarantee it.
So, clustered look, can you repeat that?
Yes. So U1 is a cluster characteristic at this point. It is a level 2 random slope. What it is the slope for is the relationship at level 1 between a person predictor and a person outcome. So it is the level 2 random slope of a person level variable, predicting a person level outcome. So how the people things are related differs across clusters. That's a random slope. Okay, how are we doing? This much better? Yeah, thumbs were like here last time. I'm trying to get them up to so-so. That's a reasonable expectation. I'm not even like being, like I've done this enough to know that the first time you introduce a really hard concept, it goes badly. And a few glasses of wine later, I'm ready to try again. Not this morning, but after, after Tuesday, I had to console myself, right?
I would have bought you a sympathy card had I known.
No, I can feel it when it's hard. Like, I can see it on your faces, and I can see it in the questions, and I can see folks just like, and I react to that. And I take it personal, but I also know that the first time you see anything, it's hard. And you just keep going back over it and going back over it, and eventually it clicks. Okay,
Would you mind, this would be helpful for me, so if it's not helpful for the rest of the group, we can do it after.
okay,
Group feedback would be good. Just giving us an example of, like, contextually, when you want to look for a random slope.
yes, I can do that.
I know you've done the SES.
Yes, so I think that you would potentially want to consider a random slope for every level 1 predictor in your model. Because even if you didn't expect it or you don't really care about it, if this predictor needs a random slope and you don't have it, the rest of your model is off to some extent. Like, things that are missing do damage. So from that perspective, from a stats perspective, you want to do it. But theoretically, what it means is you are hypothesizing another way that clusters differ from each other. It's another way that schools differ from each other, not just mean achievement, but also in their equity, right? Like, if some schools have poor kids doing much, much worse, that's not good. And the schools that are having poor kids do less worse, right, where there's less of a gap, you would want to know what is it that's causing those schools to be more equitable.
That's important.
It is important. Yeah, so it's not just in the relationship of like which schools are higher or lower or which clusters are higher or lower, but how do things function within that environment? What is the effect of person predictor on person outcomes in this one? What does it look like in this one? What does it look like in that one? Okay,
That's cool.
that's cool, it is. Okay, we've got the Zoomers loading up the questions here. Can I repeat one more time? Did I do that? No. Okay, was it the level 2 variance and a level 1 person thing? Was that the thing? Okay, so U1 is a level 2 thing. Okay, it is a level 2 characteristic. U1 is a random slope for how clusters differ from each other in the effect of a person predictor on a person outcome. The level 2 random slope is cluster variation in a level 1 within effect. And the hand dryer is louder than me. I can't talk very loud. Okay, does that help? Did I repeat it enough? Or did I miss some? Enough? Enough for now? I'll just keep saying it. Question then, how does this happen? A level 2 cluster predicting person. Can I explain it? Okay, yes. U1 is a source of variation across clusters. It's not really explaining anything. What we have found out is that clusters vary from each other in a different way than just their means of the outcome. They vary from each other in the level 1 within relationship that this is the random slope for. So in this case, it's within cluster X, the effect of having like more money than the rest of your school or something like that. So U1 is a level 2 thing, varies across clusters, but what it is about is a person relationship. That's what is varying across clusters. And when we add a random slope to the model, we are not going to compute pseudo R-squares. I don't think they make sense. People disagree with me on this point, but let me tell you why. U1 conceptually is error. Why is it that some schools are more equitable? Meh. So the fact that we've isolated this additional source of variation, this additional reason why clusters differ from each other, does not mean that we know why they differ from each other. We don't know anything about that yet. All we know is that each school needs their own slope. If this term adds significantly to the model, then there's heterogeneity in the within effect across clusters, and we got to figure out why. Likewise, U0 is an error term. We don't know why some clusters still have higher mean outcomes than others. This is everything that is not due to this one predictor that's in the model. E is an error term. That's what E stands for. We don't know why some people have higher outcomes than the rest of their cluster, even after we control for all the things that are in the model. So conceptually, these three variables in blue, random variables, because they each have a distribution, those are sources of error of different kinds. E is why do people differ from each other? U0 is why do cluster means differ from each other? U1 is why do cluster slopes differ from each other? Okay. No, not yet. Better? Any of that you want to hear again? Question?
Yes, so related to this, is there a significant difference between categorical and continuous predictor interpretation when once you added a random slope for that predictor at level 2? I mean, we know that, for example, that gamma 10 right now, that's the average effect of the predictor on the outcome across clusters.
Mm-hmm.
Is that the same for the case of continuous and categorical predictors? Or?
Yes.
Okay. Great.
Absolutely no difference. The question
Great.
was, what if this predictor is binary versus quantitative?
Exactly, yes.
It absolutely does not change anything. The slope is the change in y for a 1 unit change in x. If it's a grouping variable, a binary predictor, then a unit change is moving from the 0 reference group to whatever the 1 group is.
Okay.
It's a 1 unit change. Now, what if within cluster X here, what if this original level 1 predictor were ordinal?
We will have dummy.
Yeah, then it's not one thing, right? Then you'd have as many slopes as you would have differences that you need to put into the model.
Okay.
So like if I had some kind of low, medium, high as a variable on something, if I made low the reference group, I would have a slope for low versus medium, and I would need one other slope. I could set it up as low versus high or medium versus high, whatever I feel like, but I need 2 slopes if I have 3 groups. That would mean 2 random slopes to fully disentangle the effect of that predictor and how it varies across clusters.
Great, thank you.
Mm-hmm. But otherwise, it doesn't matter if it's binary or quantitative. It's a 1 unit change. Works either way.
Great.
Now, why do I have a cluster mean-centered variable in here? Because you need to. The short answer is if I used a constant-centered predictor here instead, I would have a smushed random slope. It's a different kind of smushing than we solved with the contextual effect, and it's much harder to solve it with the contextual effect on the random side. So please trust me, if you want, that we need to have cluster mean centering here, it's not going to work. And if you're like, I don't want to trust you, Lisa, okay, read the Reitz and Sturba article that's in press on 2023. And then you can see why I just say, just do it this way. Those are your 2 options. They have a whole lot of math as to why it is the way it is. And it blew my mind when I first read it, actually when it was presented at a conference, and I went up to them at a conference, and I was like, oh my God, like, how did I not know this? So this has changed significantly in terms of how I present this material relative to what I did 4 years ago, because I'm much more aware of this idea of random smushing than I used to be. So to prevent that, we're always going to have a cluster mean-centered version of the predictor that is given a random slope. Okay, let's talk for a second about the purple versus green here. Within cluster X is purely level 1, right? Cluster mean X is purely level 2. Are these variables correlated?
No.
They are not. We rendered them orthogonal by subtracting this thing that is right here. We literally are taking the between part out. Cough, cough, homework question. What if I had within cluster something else and between cluster something else?
Correlation will be 0.
The correlation is always 0. When you render variables level specific, it doesn't matter what they are. They're not going to be correlated. Mm-hmm.
Yeah.
Yeah. What if I had original X and cluster mean X? those are gonna be correlated. Because you form the cluster mean out of the variable, it's like redundant. But if you have separated things across levels, they should not be related. And if they are, something went wrong. There's an order of operations problem or a missing data problem or something like that.
Yep.
All right, pictures, random slope on the left, random intercept only, nope, say that backwards. Random intercept only on the left, adding a random slope on the right. So different slopes for different folks. Okay. This is the math as to why we don't want to have a constant mean-centered level 1 predictor, because the cluster mean is still being multiplied by the random slope if we do down here. All right, so we had an example that we looked at based on the continuing example that's wound its way through lectures 2, 3, and now 4. We're predicting language from 2 purely level 2 variables, homework type of some kind, homework amount, and whether the school has mixed grades. So in predicting the cluster mean, these are main effects of the level 2 variables. So gamma O1 has a 1 because it's the first predictor of beta 0. Gamma O2 has a 2 because it's the second predictor. Then we had added verbal ability, which is a student level variable, and centered that at the cluster mean. And then we took this cluster mean, put it in at level 2, and subtracted 10 to make 0 meaningful in this variable. So the fixed effects then are on the left here. Homework 2, that's the gamma O1. Mixed grade is the gamma O2. CM verb 10 stands for cluster mean verbal centered at 10 is gamma O3. And within cluster verbal is gamma 10. So under cluster mean centering, the level 1 predictor is purely the within effect. So this is the effect of having more verbal ability than other kids in your school. For every unit more verbal ability you have than the cluster mean, your score goes up by 2.45. And this is the average for the clusters, now that it's random. And over here is the new model for the variance. So you will see something that looks like this in each of the programs. The order that these terms appear varies by program, of course. But in this case, 2, stands for in the G matrix of random effects here. That is where the variance would be. This is the correlation version. So that's a new variance term. And we do a likelihood ratio test against a model without that random slope and its covariance to see if we need it. And in this case, it looks like we do. So the conclusion would be, does having more verbal ability help you get a better language test outcome? Yes or no? If I have more verbal ability, does that help me improve my language test?
Yeah.
Yes, it does. If I go to a school filled with smart kids, does my school have higher outcomes?
We don't know yet, but based on the contextual, yes.
Well, this one is what I'm doing with between.
Oh.
Yep, so yeah, for every unit smarter my whole school is, meaning cluster mean whatever, as the variable that gets 1 unit added to it, the school's outcome goes up by 3.6. And if you want to say, well, how much of that is actually just due to the person? And I want to control for person differences and talk about the contextual effect, like what if I took my smart self and I moved to a new school? Then how much would my score change? That's the 1.17, which is the difference between the two. So between minus within is contextual. Within plus contextual is between. So which of these 2 verbal effects then does the random slope operate on? Cluster mean verbal or within cluster verbal?
Within cluster.
You're voting for within?
Yeah.
Okay, anyone else want to weigh in on that? Which of these 2 slopes does the random slope go with?
Level 2, so
It's right here.
have to be within.
Yep. It goes on beta 1. Beta 1 is the level 1 slope. So yes, U1 represents the idea of cluster differences in the effect of a level 1 within slope.
Oh.
You said it right.
So it is level 2?
U1 is a level 2 slope.
Okay, all right.
It's a level 2 thing. But what is varying across clusters is the level 1 slope. That's what makes this so damn confusing. And I just saw your faces like, oh, she just made it worse. 2 steps forward, 1 step back. All right, let me try again.
I have a question.
Yeah, go for it.
Okay. Is it on purpose that the subscripts for those are the same, the 1C?
Oh, it is not it's deliberate, it's not an error. So,
Okay, like, I know, like, does that mean that they like are corresponding to the same thing? Like, to
Yes.
help me when I look at this, be like, oh, that's the connection there.
yes,
But
yes.
I didn't know if that's like intentional or, you know.
Yeah, that is deliberate and intentional, because if something is predicting beta 1, it gets a 1 in its first spot. So that is tied together. If this was beta 2, then this would be gamma 2O and U2 instead. That all has to match, or the notation system just breaks. So if I didn't have this random slope here, like, let me see if I can make my mouse block it. There, it's not there anymore, okay? Then we would just have a fixed slope. That means that the effect of verbal ability, more verbal ability than your school, is the same no matter what school you go to. What U1 is adding, hey, come back. What U1 is adding is a deviation for your school relative to the average slope. And it goes with the level 1 predictor that the beta is multiplying in the level 1 equation here. Okay. Other questions? Things you want me to repeat or clarify? This is just one example. I've got a whole nother set of examples too. And we looked at this last time. I fixed the animation fail. The solution looks a little bit different with the random slope than without. Once you add parameters to the model for the variance, those get figured out first by the likelihood estimation iterative process, and after they're figured out, then it computes the fixed effects. So the fixed effects are going to wiggle a bit. In addition to that, you can expect for the level 1 slope that now has a random part to it, so within cluster verbal, this is the fixed slope that's on average, but we know that it has a random variance around it. Its standard error is going to be higher if it has a random slope that goes with it than if it doesn't, because that random slope goes into the computation of the standard error. It will also have fewer degrees of freedom because it's going to use something that looks closer to level 2 relative to level 1. So both of those things combined can make it so that your slope for the fixed slope becomes non-significant. If you add a random slope around it, you keep it anyway. You cannot have a random slope without the fixed slope that goes with it. Random trumps fixed. But you could just have a fixed slope that's not random. The reason for that, oh, I don't need to go back, is right here. U1 is how far off your slope is from the fixed slope. They work together. So if you take out the fixed slope, you leave this part out here where my mouse is, then it's off from 0, exactly. And that will break things. All right, we did effect sizes. We can do confidence intervals. We can do reliability. We did a recap. You want to go back over the recap? Or have we recapped enough? Re-recap? Re-squared cap? No, we're good? All right. Okay. So what we are saying then, when we add a random slope, we are not explaining variance. I will die on this hill. We are not explaining variance. We are introducing a new source of variance out of our old ones. We are repartitioning our error into 3 sources. We have differences between people from the same cluster, that's level 1E, We have differences among the cluster means, that's level 2 U0 random intercept. We have differences in the effect of a level 1 predictor. That's a U for whatever number the predictor goes with. What's happening under the hood, behind the scenes, is we are creating heterogeneity of variance as a function of the predictor that's been given the random slope. In particular, quadratic heterogeneity, the happy face, which none of us has right now, but we're working our way there. I got some math for you if you care about that I'm likely going to have to do outside of class because based on how long this is, we'll make it work though. So in order to explain this new kind of variance, why is it that the person slope is stronger in some clusters than others? We need a new kind of fixed effect that is called a cross-level interaction. And we started talking about that at the end last time, so we can go back through that. Do you remember why it's called cross-level? I'll take gestures. Yeah, because it's a level 2 thing interacting with a level 1 thing. That's why it's called cross-level. If you had 2 level 2 things interacting, that would just be a level 2 interaction. If you had 2 level 1 things interacting, that would just be level 1. So cross-level is variables on different levels. Like this. So if this is following the same generic example, then we'll see some more specific variants of this. But the key idea is that we have introduced this new fixed effect in yellow here as a predictor of beta 1, which is a slope. So we have a slope predicting a slope. And if that makes your head hurt, yes. Think of it this way. If I were to distribute beta 1, like take this thing and put it in here, we would have the fixed slope for within cluster X is gamma 10 plus gamma 11 times within cluster X times cluster mean X. So gamma 11 is the two-way interaction of level 1X and level 2X. Level 1 within, level 2 cluster mean. And the reason that it would be put here, its purpose in the model, is to help explain why it is that some clusters need a different effect of this person level predictor. Question?
Yes, so I'm just thinking, like, ahead. There are certainly going to be things, times, or whatever, where we have more than 2 levels.
Yes.
We're gonna have lots of levels.
Yes,
So,
lots of levels are possible.
yeah, and like, our statistics always, like, I'm sure it gets complicated, but
Yeah.
can we always explain the stuff at each level, or do we just get to a point where it's like, like, I don't know how level 1 impacts level 7, but it probably does.
Theoretically, yes. Every time you add a predictor to the model, you should reliably be able to tell what it's for. Like there's a reason. Everything has a purpose. In practice, however, because each time you re-estimate the model, everything sort of wiggles around as to what makes the data the tallest, you can see things change that weren't supposed to.
Right.
So it doesn't, in practice, it doesn't fall out as neatly as it does theoretically. But yes, theoretically, every time you add a predictor, it has a role. And you should know, based on that, what kind of variance it's supposed to be predicting.
And then, I'm sure it's possible too sometimes that you could like miscalculate the number of levels you had, either on too many or too few.
Yes, but in order to figure out how many levels you need to have to figure out which variables have variance at each level. And they have to have variance at a level before they can go into the model at that level.
Okay.
But yes, it does get more complicated than this. I know. Not today, though. We're staying in 2 levels with like 1 predictor today. That's what we're staying. Okay, so cross-level interaction, its purpose is to explain why it is that some clusters have a higher slope of this person predictor than others. In this case, what I'm saying is maybe the effect of having more than your peers depends on how much your peers have. Right? Is it different to be smarter than everyone else if everyone's super smart than if everyone's not as smart? Or is it different to be the rich kid if you're in a school with like lots of rich kids relative to a school with not many rich kids? That's what this is asking.
So you should have an interaction for every level one.
You don't have to have the same variable. This is just because I only wanted one variable in the story. But any variable that is at level 2 that has a main effect would be eligible to participate in a cross-level interaction as well. And because this is an interaction, you would want to have its main effect in the model too. Otherwise, it's not really the interaction and it breaks the system. Okay. You want to walk through the fixed effects then? What they would mean, maybe? Because things have become more specific. So beta 1 here is what we're operating on. We have the fixed slope of my within cluster predictor. That's the within slope, I know that. But now because this within cluster predictor is interacting with my cluster mean predictor, gamma 1O is the slope specifically when this thing is 0, whatever that means, whatever you centered it at. Likewise, the fixed effect of the cluster mean, level 2 predictor, gamma 1O here, we know that's the between effect because it's paired with a level 1 predictor that's been cluster mean centered. But because it interacts with that variable, it's specifically when its interacting variable is 0 as well. So then this would be the between effect specifically when students are at the cluster mean for that predictor, which is when within cluster X is 0. Then the interaction. Every interaction you can talk about that's two-way interaction 2 different ways, right? It's how one predictor slope varies as a function of the other, or how this one varies as a function of the previous one. Usually one way of talking about it makes more sense or is more useful. In this context, I think it's more useful to talk about the within cluster slope because that's the thing that we're focusing on here, and to think of the cross-level interaction as moderating it. So then putting that together, gamma 1, takes my person slope and makes it more positive, less positive, more negative, or less negative by that much, by gamma 1. And the variance that this new cross-level interaction is targeting is the random slope variance. Why is it that some schools have a bigger effect of student money or student achievement on some outcome? Well, maybe it's because of the composition of the school with respect to that variable. Could be because of lots of things. It's up to you to decide. So in terms of your question a couple minutes ago, figuring out like what predictor are supposed to do, like what they're for, the short answer is it's always the same rule. It predicts the variance that's in its equation. Anything you put in beta 1, its job is to tackle U1 as the random slope variance. Anything you put in beta 0, its job is to tackle U0. Anything that you put in level 1 here is to tackle E. So the fixed slope of this within cluster X would tackle E. All right, okay. This is where we left off last time. Remember that much. Do you want to see some numbers? Maybe? Okay, here's some code. I added 3 cross-level interactions to my previous verbal example, because why not? Ding! And I put it in yellow because we're all tired. So here are 3 cross-level interactions I added because I had 3 level 2 predictors that were available to me as part of the story. So note the parallel here. I have O1, O2, O3. The second set of fixed effects is 1, 1, 1, 2, 1, 3, because these latter 3 fixed effects are regarding beta 1, whereas the first row is regarding beta 0. So that's why it starts with 0 and then starts with 1. So in this solution, the intercept is predicted outcome whenever predictor is 0, right? So that's for a school that gives out homework of 2, whatever the hell that means, that does not have mixed grades, whose school average verbal score is 10, and for a student who has average verbal ability relative to their school. So the main effects of the model establish the conditionality of what the fixed intercept means. Adding interactions doesn't change that, because those variables were already part of the story. And any two-way interaction that you add has to have its corresponding main effects in the model already, or it's not really an interaction. That rule has not changed. So the way that I would talk about these three cross-level interactions, and again, they're cross-level because within cluster verbal is a level 1 person thing, and each of the interacting predictors is a level 2 school thing. The within cluster slope here, that is specifically when all three of these interacting variables are 0, is positive. So that means my cross-level interactions can only do two things. They can make it more positive or they can make it less positive. That's it. So if I look at homework 2, it's making it less positive non-significantly. So for every unit more homework a school gives, this slope, 2.39, becomes less positive by 0.05. Same pattern with respect to the within slope being moderated by the cluster mean of verbal. It's making it less positive by 0.04 per unit cluster mean. The one that happens to be significant is in the opposite pattern. It's a positive cross-level interaction. So that's making the within effect of verbal at the student level more positive by 0.32 in schools that have mixed grades. So these three new terms, their purpose is to capture random slope variance. Why is it that some schools have a stronger effect of student verbal than other schools? Well, maybe it's because of the amount of homework they give or their mixed grades or the composition of the school with respect to verbal ability. Turns out, just mixed grades in this data set. So I would compute a new pseudo R-square for how much my random slope variance went down relative to the model, where these three things in yellow were not there. That's my new baseline. And it explained a teeny tiny bit of variance in the end. Teeny tiny. Okay. Danger ahead. That's a good transition point. How are we doing? Can I get a thumb gauge? A wiggly thumb.
Clarification question. So you had said that the random slopes don't explain variance.
Correct.
So when you computed the new pseudo R squared, can you repeat how you said that?
Yes.
And what you meant?
Okay, let me back up like a couple slides here. So when I first added the random slope in this example, it was right here. This is slide 10. It doesn't have anything predicting it. So conceptually, this is like my new baseline model, because this is all the reasons why schools need a different slope. I don't know what they are, I just know that they are. And those reasons worked out to be, let me find the number, 0.2239 of a variance, okay? So that's my new, like, the most variance we can have. It's kind of like the new empty model, but with respect to the random slope. So then after I threw in three cross-level interactions, it is 0.223, which looks like the same number, but it turns out it's just much smaller. But that's my new effect size. So these three cross-level interactions did explain at least a teeny tiny bit of this random slope variance. But adding the random slope in the first place did not explain variance. It repartitioned it into three kinds instead of two. Okay, is that better? Okay, excellent. Every time you add a random anything, you are not explaining variance. You are repartitioning it. That's a general rule. I do not think it makes sense to think of explain variance via random slopes, because they're error terms. They came from the error term. All right. So these examples here, like this little story this is what I did in my APA workshop. And it was like the end of the second one, and I was like, ta-da, see, there you go. Now, do you know why I did it for the cluster mean centered version of this model? Any guesses? Oh boy. Because if I didn't, I would have had to have like 50 more slides explaining why. And I didn't want to. But you guys get the 50 extra slides. It turns out you can't learn everything you need to know to do a good multi-level model in 2 hours of workshop.
It was enjoyable, though.
I'm sure it was enjoyable, and I'm sure there are people who came away with a very false sense of confidence as to how much they learned in 2 hours. I'm here to tell you this, workshops do not teach you things. They can, they have them because people think that they're just gonna get up to speed if they just really like drill into this for like 2 days, and I'm gonna learn it, and I'm gonna be able to do it, and that is not how cognition works. Workshops are really good for getting you into a topic that you know nothing about. Like, I had never heard of multi-level before. What's it for? What's it like? What purpose? And hopefully you would learn enough to know whether you need to keep going or, oh, okay, yeah, I don't need to know this. This isn't my world. Like, there's certain statistical techniques that I started reading about, and I'm like, yeah, I don't need to know this. Like generalized estimating equations. I know very little about because I got to the part where it said, missing data are assumed missing completely at random, and everything has to be balanced. And I went, meh. There went that article. That's never going to be me. I don't need to know this. So workshops could tell you, do I need to know this? Workshops are also really good, like if you go somewhere for like 2 or 3 days, for people who've been banging their head against something for like years, and it isn't like clicking, and they want someone to just talk to about it. Like those are the people that get a lot out of workshops in my estimation. But the human brain is not designed to like absorb everything you need to know in the level of detail and complexity at which you need to know it in 2 hours. It's just not going to happen. And I hate to break it to you, but it's not going to happen in 1 semester either. Right, Nikki?
No.
She's like, I've had 4 classes and I just now got this. Yes, and I've been reading this and trying to work in this area for 20 years, and I'm still uncovering nuances that I did not fully appreciate. It's a process. So yeah, I took the easy way out for my little 2-hour workshop because I only had 2 hours. But there are valid reasons why you might not want to set up your model this way using cluster mean centering. If you want contextual effects and you want those to be model parameters, you would not set up your model this way. Then we have some issues in terms of how to get random slopes and cross-level interactions that are still specified correctly without smushing. And that's the next section. Question, will I offer an advanced clustered MLM in the future? No. The answer is probably no. Not because I couldn't or I wouldn't want to, but because I'm out of degrees of freedom with respect to all the classes. I already teach 6 classes on a regular basis. I don't have room to do more, otherwise things get dropped off. And I would, before I would add an advanced clustered, I'd add an advanced structural equation modeling, because that class has way too much stuff packed into it. Coming back in the spring, for those of you who want to play along, yeah, I could envision like an advanced multi-level SEME kind of thing that brings in both of that stuff, because there's a lot of overlap once you get to that point. But you know what you can do? You can read. You can take all the things on your reading list and like do yourself an independent study with those. That will help. All right, so danger ahead. So let me back this model down in terms of its complexity. In the previous analysis, we had homework not mattering, and mixed grade mattered, and verbal mattered as a main effect for the cluster mean, but it did not matter in terms of the cross-level interactions. So I took out those 3 fixed effects, and I'm just working with this, okay? So right now we have one level 1 predictor, which is how much more verbal ability you have than your cluster mean. We have 2 level 2 predictors, mixed grade and cluster mean verbal ability. Mixed grade has 2 different fixed effects. Gamma O2 is its effect predicting the intercept, which we would call the main effect in terms of interaction language, whereas 1-2 is the effect of mixed grade in moderating the within slope of verbal. And note, I'm skipping 1-1 because I already used it for homework. I'm keeping the numbers sort of internally consistent. Okay. So because we had cluster mean-centered student verbal, this cross-level interaction has an unambiguous interpretation. It moderates the within slope, the end. But if I had used a constant-centered level 1 predictor, then we're in dangerous waters. We would have smushing of two different kinds that are new, the random slope and the cross-level interaction. So I want to show you how to fix those things, but not much this time. So introducing a slightly novel spin on the model that is known as a hybrid model. Yeah, it sounds fancy, huh? Where we're going to have different versions of the level 1 predictor as a fixed effect than as a random effect. Looks like this. So I am keeping cluster mean verbal here. I've attached it to beta 2, but I've added constant-centered verbal with it. So I have both versions of the level 1 slope in the model at the same time. Now note what I did to them at level 2. Beta 1 has a fixed slope, no random slope. Beta 2 does not have a fixed slope, but it does have a random slope. So these two things are working together across these two variables to capture the level 1 effect. That's why it's called hybrid, is because the fixed effects part of the model are set up as within contextual. The random effect of the model is multiplying the cluster mean centered version so that it stays purely with respect to the within slope like we need it to. A composite equation, then putting it together, looks like this. So gamma O2 is the main effect of mixed grade. O3 is the main effect of cluster mean verbal. 1O is the main effect of constant-centered student verbal. That means that gamma O3 becomes a contextual effect rather than a between effect. And then we have our random intercept, our random slope. So note that the U2 is multiplying the cluster mean-centered version of the variable. And then we have our friend E. So this is what I would do if you want to have constant centering because you think it makes more sense, like if you have a binary predictor that's 0 or 1, or if you're interested in contextual slopes, or if you're pulling level 2 information from a different, more complete source rather than the cluster mean. Like if you have some sort of like school level data set that's separate from just the students you have sampled that characterizes their school, that would be a better place to pull level 2 information if you have it. So this solves the potential for random smushing in terms of the U2 multiplying the level 2 part of the variable in addition to the level 1 part. Using cluster mean centering for the random slope makes it that it only multiplies the within part, and it's the cluster difference in the within slope as we want there. Okay. Are you with me? Maybe. To do it, here's some example. You just stick a different version of the variable in different places in the syntax. Like, oh, is that it? Yeah, that's all there is to it. So here's Elmer. I got verb 10 right here in the list of fixed effects, and then inside the parentheses where the random effects go is the within cluster version of it. Likewise in Stata, I've got verb 10 here in the fixed effects, and then after the bar, which starts the random part of the model, I have the within cluster version. And the same thing here in SPSS and in SAS. So that's how you would solve that problem. Here's what it would look like if I did not solve this problem. So on the left here is the amount of random slope variance for the cluster mean centered version of the level 1 predictor, which is 0.224. On the right is what if I had not known this was a problem and I fit a random slope for the original constant centered version, I get a 0.1996. These numbers are not the same. The one on the right is wrong. It reflects not just slope variability, but also intercept heteroskedasticity. So we don't do that. We got to make sure that it's the cluster mean centered version. The rest of these numbers are also different from each other because of different definitions as to what 0 means. So a score of 0 for the level 1 predictor on the left-hand side, for within cluster mean centering here, means you're at your cluster mean. So that means the random intercept variance is specifically at the cluster mean, differences across clusters. On the right side, a 0 means you got a 10. And so the random intercept is specifically across clusters at the location of 10 for the predictor. So they're not the same. Do I have a picture? Yeah, I do. Let's do that and then we'll go home. So this is the same picture, doctored to make a point. If I only have a random intercept, then how many ways do people do? Nope. If I only have a random intercept, how many ways do clusters differ from each other? If I only have a random intercept. This is a finger question. If the model only has a random intercept in it at level 2, how many ways do clusters differ from each other?
1.
1. In this, right? Their intercept. These are parallel lines. So that means that if I think about U0 as how far off my cluster mean is from the average, U0 would be the same if I did it here, or if I did it here, or if I did it here. They're parallel. Now if I come over here, now what I get from my random intercept depends on where 0 is on this x-axis. Because just as your intercept is the predicted outcome when your predictors are 0, the random intercept is the predicted outcome when your random slopes have a 0 value for the predictor that it's attached to. It's the exact same concept, but on the random side. So the differences between clusters and the intercept are specifically when this level 1 predictor that has the random slope is 0. So they'd be smaller, for instance, if 0 were here than if 0 were out here. The random intercepts are conditional on the 0 value of the predictor that has the random slope. So it means something different. All right, 1:45. Time to be quiet. Questions? Comments? No. Okay, not now, at least. Then that means you get to start working on your formative assessment. I will tell you there's one problem that we didn't yet talk about, but we'll see if you can solve it, and if not, we'll talk about it in class. So I have that open for you. You can work on that before Tuesday. No homework out at the moment, but you can start planning for homework 4. Let me know if you need anything. Thanks for being here. Bye, Zoomers. Bye, Roomers.